Alright, so in this next step, step 5 and 6, we're going to build this circuit, but before we do that, we're going to measure the two resistance. We have a 100 kilo ohm resistor and a 1 kilo ohm resistor, and we get the 1 kilo ohm from this diagram right here. So let's see what the actual value of these two resistors are. Alright, let's see which one's going to be easiest. Well, let's just disconnect them all, because it's all going to change anyway. Move this out of the way. Alright, now let's see. $99.1 kilo ohms. I was just checking to make sure this was on camera. Let's see. Let's see what this is. 0.983 kilo ohms. All right. So I'm probably going to fast forward this step, but I'm actually going to have to take my time when creating this circuit, because it actually says to reduce noise, make all your connections as short as possible. And that's just so it's not picking up any radio waves. For instance, we have a nice 60 hertz sine wave right here, and that's extremely close to the rest of the circuit, and they can talk to each other, I bet. So let's try to make these leads as short as possible, and you just have to make it as short as possible with reference to the ground source. Power sources, they're kind of give and take, but your ground is the most important. So let's see how clean I can make this one. Okay. Ooh. Okay. So, all right. So I have essentially this circuit built as close together as I can, making the leads that are pertain to the circuit as short as possible. And what I did is, in addition, is for the power supply, the voltages going into this little circuit, I put extra smoothing caps on there. And that's just in case there's noise traveling through these long wires. These smoothing caps should knock that out pretty well. The resistors, I trimmed the leads pretty much as short as I could get them. And then I have this little ground bridge coming over, and that's, again, as short as I could get it. I guess I could trim the leads on this transistor, but you know what? Transistors are cheap. Let me just crop these a little bit. All right. So now it's safe to say, at least for a breadboard, this is as condensed as I can make this small little circuit. Now, let's see what the procedure asks for. Well, it asks for you to take an initial measurement. Okay, let's see. Power supply 2 needs to be 9 volts, I believe. Okay, so PS2 needs to be 9 volts. And I believe this is PS2. Let me make sure of that. Yeah, so this needs to be 9 volts. So I need to use that trimming pot. And looks like PS1 is actually going to be the value that we're going to be varying. So let's set PS1 to 0 volts and then set PS2 to 9 volts to start. Now to set that, all I'm going to do is remove this lead over here, and I'm just going to tag it to ground, and that'll make it essentially 0 volts. With doing the smallest amount of variation to my circuit. Now let's power this thing on and see if anything smokes. Okay, so 0 volts. Let's verify that PS1 is 0. Okay, that's indeed 0 volts. Now let's set PS2 to 9 volts. Well, I guess that's as close as I'm going to get. So let's just say 9.06 volts. Yeah, that's a great connection for that one. Okay, but this is just for quick adjustments. It doesn't. These are the numbers that actually matter. So PS1 is going to be needing the adjustments, and PS1 is right here. And okay, so we're gonna start taking these measurements, starting at PS1 being 0 volts. Let's see, VBE. Good. Okay. So this will be VBE. This one will be VCE, and then this will be power supply 1. So that's a fairly easy thing to remember. So far we have 0 volts, 0 volts, 8.99 volts, And we're just going to run through this with 250 millivolt increments until things get sensitive, and then about 20 millivolt increments when things are sensitive. So let's see what we can come up with. Take 3. 200 millivolt steps. No. 20 millivolt steps, not 200 millivolt steps. Jeez. Wow. Let's do this one last time. One last time, I swear. Okay. And that is not letting me do that. Let's see what I have. Oh. Okay, so this is actually the appropriate tool to use for these little trimming pots. It's basically just a little cylinder with, sometimes it's just a little piece of razor blade. But this one is a little fancier than that. It's a really thin piece of steel. And you just stick it in there and you wait for it to kind of line up. I have a smaller one somewhere, but I don't know where it is. There we go. So that'll actually keep the screwdriver on the potentiometer for when you tune it. And I'm glad I decided to use a trimming pot because this is very touchy. Anywho, so let's do this. Well, that was a royal pain. But it's done.